Here we'll do more polynomial modeling practice. We're going to begin with a box that has a square base and no top. We're told that we're building it on a budget of $20, with the base costing $2 per square foot and the walls costing $1 per square foot. We're going to let the length of the sides be x and the height be h. Notice that since our base is square, the length and the width will both be labeled x, but the height will be labeled h here. We're asked to write an equation that models the cost of the box in terms of x and h. In order to model the cost of the box, we're going to have to find the area of each piece of this box and multiply it by how much it costs. We're going to look at the base, and we'll also look at the sides. We'll have a look at the area, and then have a look at the price. For our base, we can see that the bottom side of this box is x length times x width. Therefore, we'll say the area is x times x, which gives us x squared. Now, if we look at the front face of the box here, we can see that it's a rectangle that is x wide and h long. Therefore, we'll say that the sides are x times h. However, we'll have 4 sides on the inside of this cube. We have an hx side in front, there's another one in back, even though we can't see it, and then one on the left and one on the right. So we're going to have 4 sides that are x and h, a front, back, left, and right. So we'll say x times h times 4 will give us 4xh. We're also given that the price of the base is $2 per square foot. So our price for the base will be 2, and our price for the sides is $1. So if we multiply the area of our base times the price, we get 2x squared. Then if we take the area of our sides, that's 4xh times 1, we will still get 4xh. Therefore, we'll say the cost is equal to 2x squared for the base, added to 4xh for the sides, and since there's no top, we don't have to include it, because this box, as stated in the first line, does not have a top, so that won't cost us anything. We are also given the total price is $20. So this means this 2x squared plus 4xh must equal 20. This is the equation that models the cost of the box in terms of both x and h. We've just taken the area times the price for each part of the box. We'll carry this forward to our next part of the question. The next part of this question asks us to solve the cost equation for h. So we'll box in h in red and try to get it by itself. To begin, since we want to get h by itself, let's leave the 4xh alone for the moment and subtract 2x squared from both sides. If we subtract, we'll get 4xh is equal to 20 minus 2x squared. Then, to get h by itself, we'll divide everything by the 4x. When we divide 4xh by 4x, we'll get h by itself equals 20 over 4x. If we take 20 divided by 4, we will get 5. However, note that x is on the bottom here, and so it must stay on the bottom, and our first term will say 5 over x. Then we'll have minus 2x to the second over 4x. If we take 2 divided by 4, we look at the constants in front, and 2 over 4 will give us 1/2. Then x squared divided by x, we'll knock 1 power off the x squared and change it to first, and cancel out the x on the bottom completely, and so we'll have minus 1/2 x, and our height will now be 5 over x minus 1/2 x. Now that we have height, we can move on to part C, where we're asked to write an equation that models the volume of the box in terms of x. The volume of a box is just all 3 sides multiplied together. So we can say our volume is equal to x times h, or if you wish, x squared h. So we'll say our volume is equal to x squared h, and then we can replace h with the expression for height that we just wrote. We'll take the 5 over x minus 1/2 x and replace h with that string. So we'll have x squared times 5 over x minus 1/2 x. If we multiply x squared times both of those, we'll have to be a little bit careful about the fraction math. For the moment, we can write it as 5x squared over x minus 1/2. And then if we take x squared times x, we'll end up with x to the third. Then we can cancel down the 5x squared over x. Once again, we'll knock one power off the x squared to change it to first, and then cancel out the x on the bottom. This means our volume will now equal 5x minus 1/2 x to the third. This will be the equation for the volume of that box. For the next part of the question, we are asked to find the dimensions that maximize the volume of the box. Since this function is a third power function, we're not going to have to do it by hand. So instead, we'll go to a graphing utility and look for the maximum. Here in my graphing utility, I've input my function, and to find the maximum, we mouse over this place where we see the peak. We'll click on it, and it gives us an x and a y. The x value, 1.82574, will be our value of x that maximizes this, and the y will be the volume. I've copied it onto this presentation, and I'll make a note that the x value comes first and the volume comes second. This means we've completely answered Part E. Part E asks for the max volume in cubic feet, and so that will be 6.08581 cubic feet. We've actually only partially answered Part D. We know the x is going to be 1.82574. This will be the length of our square base. However, when the question asks you for dimensions, it's not enough just to get the base. We'll also need to get the height. So we'll use our equation for height that we found in the previous part, and we'll take 5 over x minus 1/2 times x. We'll replace that x with this decimal number. It turns out if we enter all this into the calculator, we'll get a height of 1.82574 back again. So that means the base length and the height will be the same in this case if we're trying to maximize the volume. So we can say our dimensions will be 1.82574 by 1.82574 by another 1.82574.